Well, I think, well, I don't know. See what the people want.
What the people
were making a specific proposal here is, I think you were rushing.
Okay, just
kind of
yeah,
deadline,
okay.
you were rushing through that at the end.
Yeah.
I thought it'd be useful after lunch just to go back to what
Yeah.
that proposal is.
So I don't think from what we've talked about there's any real objection to this loosest structure at this level. So the idea that we're going to have an infrastructure thing that implements some of these routines and more. So that's okay. So let's just go down to the summary.
I had thought about one of those things you brought up actually, but I think that a conception of a function space is a lot like a bundle. So it's the collection of fields
Yes,
that have the
same
concept of, yeah, exactly.
Yeah.
I'm wondering if that's so, because you were raising the issue, so we would like to have a layer that's a thin layer that isolates ourselves from that, and that might be a mapping. We might have a mapping from a function space concept which is implemented as
a bundle.
A bundle.
That would be if that was all it was. That would be lovely.
I suspect they're going to be a bit different because sometimes you want to exchange halos for these 4 fields, which may or may not live in the same function space. There may be 10 other fields that live in the same function space, but we don't want to exchange their halos.
Or do
do
you always have to exchange, if fields are in a bundle, do you always have to exchange their halos at the same time, or you can't do them individually?
You can do them individually separately.
It's an association.
You can unbundle. You can have an unbundled version as well as a bundled version. But
Okay, so I think that goes with that.
I mean, a bundle is just a sack. You put them in, so you can do them individually. But
but they have to have the same structure, right? Because the point is
the data in there.
There's no gains if you don't use the same structure for them all. In fact, you go the other one.
So if we have to exchange, say, structure and logic at the same time, which is not an unusual operation, then there isn't a synergy.
You can mix 2D and 3D together, and they've done that.
Okay.
That long, there's big advantages to doing it. But if they've got different shapes,
you have to do. They have to have separate routers. Yeah. Okay, so
to get to this summary, there was a proposal, and that was, I think, if I remember rightly, not to use any specific entirety of.
So there was that, this slide, the proposal slide. Okay. So sorry, it started too late. So the proposal was that we shouldn't require the model developers, scientists, people to write ESMF code for a number of reasons. And what we should do is hide the functionality we need behind an API that the Met Office owns.
Okay.
That's the principle. So it's an implementation neutral API is what I call it.
Although implementation neutral is kind of you're never really truly implementation neutral, right? I think we have to design that API with some conception of what the thing that implements it is.
But the things we're looking at provide such similar functionality. I mean, one uses global seg maps, one uses disk grids and all that lot. They're basically doing the same jobs in a different way. So I think we can do that because our prototype code is beginning to show that this API is possible at the level we need it.
So that's useful because this morning I took it as being an implication that none of them provide all the functionality we want, and therefore we'll pick the best bits of each.
Well, there's an intersection and a union issue. Yeah. There's a union of all the functionality that would give us everything, and that's messy. There's an intersection where the two infrastructures, ESMF and MCT, provide the same thing, like Halo Exchange, and we can choose either. Yeah. But then there's some stuff that ESMF provides that the others don't. Yeah. So
and going this way allows us to pick and choose which.
Yeah.
And we define the semantics at the Met Office owned API layer.
Yes, exactly.
We may end up using only ESMF actually underneath, but it's still worth having this layer because ESMF is a really big complex beast, and I think providing the bits that we want to see rather than
that sounds good.
And providing a layer which causes people to not have immediate access to things that they could do harm with.
Probably more important.
Yeah. And,
The child safety catches.
yeah. One idea of the API is that it would actually simplify the user's interface to these complicated things, and only provide them with the functionality they need.
Right, because ESMF does also more than what we need.
Yeah.
And we want to pull it back to what we need.
Yeah.
A 20-page document for the API.
Instead of a 200-page document.
Yes.
Yeah. Yeah.
And actually, if you try and understand it, it doesn't seem to have anything that you need within that massive document anyway.
Yeah.
In the extended version, the 2000-page document.
It's all generated from the code.
Oh, that's a really dangerous thing to do.
So that is the summary, really, I guess.
I guess that doesn't, Steve, that you would follow.
Useful in
It's
certain
just
circumstances,
blue.
but
Oasis fulfills a different need.
documentation.
So just Oasis fulfills a different need.
Oasis
So we have Oasis and
Well, ESMF also allows coupling, but it's, ESMF don't want to do coupling to separate executables, but they're working on that, aren't they? So, there are developments in this world.
This sort of comes back to something that was said earlier as well, which is that, if I understand this correctly, an ESMF implementation of our infrastructure API would involve ESMF providing a lot of the infrastructure, whereas an Oasis implementation would involve a lot less Oasis and a lot more stuff here, because
You don't give us any internal stuff only.
Yeah.
Yeah, that's right. I think the real choice is between ESMF and MCT for this infrastructure,
yeah,
Halo Exchange and stuff. Oasis is coupling.
and in particular we haven't at this point seen anything that makes us think that those are not suitable, thank Christ.
And they're not mutually exclusive either. So we were talking at lunchtime. If you've got a field coming out of a model that needs to go to two models, so we're coupling. If one model is the ocean model, it's Nemo, and it needs Oasis. You can use Oasis to get that field coupled to Oasis. But you could use a different technology to couple it to something else, just argument passing into the CIs, or even ESMF into another ESMF compliant CIs. You know. So they're not exclusive, these things. But we wouldn't see any of that. I mean, it's the same argument of separation of concerns. The computational scientists would deal with that stuff. The users would use the API to say, this field needs coupling. We do whatever was appropriate.
So, to the extent that I understand it, is MPAS provides another type of infrastructure.
Yeah, they have their own solutions to several of these things.
So we have only talked here about ESMF
Yes.
MCT. Is MPAS still on
Well, I haven't looked in detail at MPAS's provision of Halo Exchange, for example, because the MPAS code
They write it
is...
themselves.
Sorry?
They write it
Yeah,
themselves.
they've written their own, yeah.
right?
And the MPAS version we've got is more about swapping out one model for another, so it's more at the data model side we've been looking at than the infrastructure
That's
side.
my follow-on comment was talking to Bill Scammeron and Tom Ringler last. One of the key things they espouse about that night is the idea of a registry.
Well, that's the data model side. Yeah. So, I mean, we can't say a bit about that, can't we? Because you've looked at it in particular, I think, the registry side.
Yeah,
Yeah, it's a while ago, isn't it? Yeah.
Going down this route doesn't preclude picking up something like that.
No.
I think the idea is that you need to try and, if as much as you can, you need to try and split. If you're coding any of this infrastructure, so you have code for that. You need to code it in a kind of a so it doesn't understand about the data model. Everything is independent of the data model. And then the bits where you have to be specific, you then have to generate that from the registry. So that allows the bits which need to understand about the specifics of the model need to come from a kind of a specification of the model's data. So that's sort of what we're really doing.
I think at this level, it might change the nature of this thing, wouldn't it?
It might do.
I
Yeah.
think it only changes the implementation, doesn't change the... I think that there's a pretty robust concept of a field object, and that field object so there's a concept of field operations, of which Hello Exchange is a good example, Put's another good example. And at the fields operations layer, and this is the layer that the user thinking the algorithm's corner sees. They don't see all the field operations, but things they see are field operations. Then there's just a field object, and fields, and there are matrix objects and other things that are field size, and they have well-behaved semantics, and all of these decisions really don't change the semantics of that layer. They have a much more significant impact on how the left-hand side is done, and especially on how things like puts are implemented and so on. But the important thing is that if you're using that top right-hand box, they're just field operations.
And all they really require is that the thing you pass in is just it's a single data structure for the whole data, so that they want to just carry this thing around and not know what's inside.
Which is a good idea.
Yeah, and I don't think that's incompatible with
Yeah, when
No.
you need to know what's inside it, that's when you visit the registry. That tells you.
Well, you could do it as a runtime thing. Yeah, you could have a runtime step, but the way they do it is they actually have it as a preprocessor, where they actually go and actually compile. So you basically hash include the bits is the way they do it. Whether that's a good idea or not is debatable.
You have actually includes everywhere.
The
and
concept
they're generated.
is that you have this information encapsulated somewhere.
And the motivation is so you can swap one model for another,
Yes,
basically.
because the generic bit of the infrastructure knows nothing about the model. It just knows it's doing something with something.
Sorry, whether the appropriate time or not. Again, it cropped up this morning about time step, and I think early on one of you guys presented the difference between Morph and MPAS. And one is where you do time steps deep down, and the other one is you do the time steps on the outside. Here, we're saying time steps on the outside.
I think Wolf's approach is the right one.
Time steps outside.
Are you saying MPAS is inside?
Yeah.
Is it?
Yeah.
You can want a couple different models. You kind of have to. Yeah.
So I think time step outside is a consensus position in the community as a whole, isn't it? It's the
Well, if MPAS is not doing that.
that's true. Actually, that's surprising.
I'm really surprised. You sure that's right? Yeah, Bill said it was. Yeah.
As far as I know, as the code looks like that. And then if you look at their diagrams, they have it all. It's inside. So it seems to be like a manual coupling. I think they do a manual coupling. And so
For us anyway, we're clear that we have a consensus anyway, we want time step on the outside, that control.
It gives you control of the control.
I mean, it's very handy with Warp that you can just change so many things on the outside, and you don't have to do a recompilation, or you can really at run times. And that's related to the time. It's one of the big advantages.
Okay, so
Sorry, Graham, can I just one?
Yeah.
You said at the beginning of the presentation about interaction with the SMF community as a whole, and whether or not the Met Office would want to get involved in that.
yeah.
If we were to go down this proposal you had, would we need to interact with them, or could we just deal with that outside?
It would
Just
be.
handle any changes that they...
I think it would be independent. Yeah.
I would say it gives you an opportunity to not interact with them. You
Yes.
just use the bits that work.
Yeah.
And it gives you an opportunity to interact with them where you want to add things that don't work.
Extending. Yeah.
So-
I think that there's a strategic reason why the Met Office, I suspect, would want to do that. Right? If the Met Office is going to bet the farm on more or less, like so, whichever one of these you do, you're going to invest a lot in making that work. And so there's a really, and while ESM, I don't know very much about who makes it, MCT, but ESMF at least is kind of has big US institutional buy-in, which is a good thing. On the other hand, they can also decide to stop buying, and I would strongly suspect that the Met Office would want to have a pretty wholehearted engagement that meant that the Met Office became one of the people who had some influence on that process.
And why that we could sort of forget about having the interaction and just, because we're hidden, it's all in the lower level.
Yeah.
This gives us the flexibility.
Yeah.
Well, it won't be hidden from the people whose problem
Well,
it is, right? So the ESMF is something which is solving a computational science problem, and the people who have to solve the computational science problems at the Met Office will be incredibly aware of it.
Just wondering, like did version 1 of SMF is completely different to version 6, completely different APIs.
They've
So
already
as-
decided from 5 onwards it's going to be backward compatible.
Or forever. Or
Yes, forever. In perpetuity. That's what they decided from 5.
Like the x86 architecture.
And what a great idea that was.
But these are the things you can either just take it as a package and use it, or you could choose strategically to get involved with them to influence
Our
it.
experience has been, I mean, we know some of the developers, and our experience is we asked them a question about something that we didn't understand, and they came back to us and said, oh, do you want to put a ticket on that? And we'll see, we'll do it to our review board, and we'll see if we can put it in the next release. And they really were quite, so I mean, even without having any kind of pressure there, they seemed quite responsive. But if you were on the board or something, then I guess you'd...
So the sort of a concern about ESMF is it hasn't been taken up by a big US model. So on the other hand, that might mean that they'll be very interested in our interaction.
So this came up last time when ESMF came up. One answer is because ESMF is such a full-on replacement for stuff. It's not amazingly obvious that you would retrofit it.
Yeah.
So you probably would only choose to do it if you were in the gung-ho position of starting out, and that possibly explains why it's not in use all over the place.
So why replace something that already works is the line.
But I mean, to me, it suggests the Metaverse should be having a dialogue with ESMF. It might be having a dialogue with Oasis, and then you can suss it out. I mean, if it's only an interim step, in that we use some of the functionality behind an API while we get to wherever you really want to be, that's fine. If it becomes a good thing to pile in and support ESMF and promote it and its development, that's a choice, isn't it? It's there now and the stuff in it works and it does some of what we need.
And maybe it'll help with I know later, because we haven't.
It might well,
Yeah.
Okay. Do you want to swap to data model then? So
just the consensus check. My judgment of the temperature of the room is that this general approach makes a lot of sense, and that's what we're going to do.
Until it doesn't work, yeah, but it's
right. So any dissenters?
Good to me as a person who will mostly live on the right.
Yes.
I can live with it.
Well, the even better thing is, if we buy into ESMF, which has a very strong object view, you don't necessarily have to see that on the right-hand side. You can do whatever we want. It can be morphed into, mutate. This is mutable, isn't it? We can mutate it into whatever ESMF actually needs behind the API. So that's a good thing. So I don't necessarily have a lot to say about data models. I think it's, the issue is none of us have particularly really got together to actually go into any depth on the data model. I'm not even sure we know quite what we all mean by data model. This is one of those questions, isn't it? So we could at least promote a discussion on that. So what did I have, my thoughts on this was, it's still an open subject. There's this object versus DDT based thing, which are not so different actually. So
actually, in the language we've chosen, they're not different.
They're not different at all. Yeah.
In Fortran 2003, there isn't really a difference between those two.
But 2003 does support proper objects with methods and things.
But they're supported by putting additional functionality into derived data types.
Yeah, exactly.
So actually, there isn't really a difference.
Yeah.
And most of the discussion we've been having is not been talking about objects in that classic object oriented sense.
That's it's just
well,
I think the fields really
are
are objects in a rather classic sense.
would be a lot of it's been talking about packing data together. So
just an
you've got all the
encapsulation
metadata to go with the grid
Yeah.
field as one package.
So DDTs or structures in C are the kind of thing people ought to have in mind, I think, when we use the word object. Is that fair? Okay.
Sorry, say that again.
So for people who are not familiar with object terminology, if you're C programmers and you use structures, or your Fortran programmers you use derived types, that's kind of the functionality we're talking about. When we say object, it's that the functionality that it provides, rather than some of the other stuff which we want to talk about. So I think we had me and Rupert had a view that we like to be quite flexible in terms of what the scientist developer uses, and I think that's turned into the very low kernel level. We want maybe something that might be slightly different to what's viewed above. So this is the whole issue of at what level do we dereference from objects into stuff that's going to be used in the kernel.
So we can all agree we probably want to have objects.
So we can agree we want to have objects.
And
At some level, we want to dereference them so the kernels can use them.
Yeah, and we need to have them in arrays at the bottom level at some point.
Okay.
So there is a question of do we dereference outside the kernel or inside the kernel?
I think David wanted to dereference outside performance
the
reasons,
kernel.
is that right?
For a combination of
Yes.
performance and, I suspect, although I could be convinced otherwise, there's a certain level of kernel sanity about that as well. But there's certainly a case, at least if you think about what you want a dynamics kernel to do, and the dynamics kernels look like LibNS implementing tense reductions, basically, and you would like the compiler to have tons of information at local level about what that means, which preferably means handing the compiler flat arrays with fixed bounds on rectangular data structures and
So I'm
things
hearing
like
a
that.
yes, we want to dereference outside the kernel.
Yeah.
I think for the science writer as well, it makes it a bit more transparent. They don't have to understand how dereferencing works. So if for somebody writing kernels, it's more like what they're used to.
So there's a subtlety here, and the subtlety here comes about because if you want to have these, if you want to have, what's the word you use? Malleability. If you want the concept of malleability that's being presented, this actually complicates things somewhat for the program. Because if you think about, can I scroll some stuff on the board and try and draw some pictures, and then we might be able to see what. So if we think, let's just for the moment think about what happens when we start doing operations in the vertical. So we're trying to do our assembly approach in the vertical, and we've got a kernel which can apply somehow over the vertical. And so suppose we've got, so let's project ourselves into XZ because my 3D drawing is rubbish. And so suppose in XZ,
Z goes up.
so right? Know where we are now? So suppose we have data associated at these points, and suppose we're doing a classical finite element type assembly approach, where what we do is we integrate over squares. Just an example, but these sort of look like this. So if I have an integral operation which operates over here, and I have an integral operation which operates over here, and I have one that operates over here. And that's sort of the way that stencil overlaps work in finite element space, and they're sort of constrained about how they work. In finite difference space, if we did high order differencing in the vertical, life gets much worse because the stencils can go miles. But let's just do this one for the moment. Then the reason that, one option would be, so if you think about then what you have to write locally in order to do this. And suppose for a minute we have some field that we'll call T, and we want to calculate the TDZ in this field. So you're going to have your routine, and you get passed in. So let's just do one element first. So I get passed in 40 values. So then this is quite easy. So I have my sub kernel T real and so T is going to be 2 by 2, so because we've written stuff out in horizontal vertical form, which is sort of how we think we might want to write these things out. And so now, oh, and I've got to return so I've got to return a dt, and dt can live here just to make it life easy for them. Oh no, I need dt to come out in the corners as well. So if I write, so dt1 equals some expression involving t, dt2 equals that as well, and so on. So now I've done that, and I've written that just in terms of my local conception. Now what happens if I want to be able to instruct this kernel to execute 2 layers at once? So now what happens in here is, so I've got some sums here which are t say, and I have to now have some conception of the relationship between what gets passed in here and my halo, and my stencil. So I'm now getting past t, and it's the right way around. That one there is fastest, so it's probably like this now that I've got past in. So it's 2 across 3 up. If you think it should be the transpose of that, I'm happy to make it the transpose of that. I'm not really very worried. Now I have to worry here about getting the so I've got to immediately do some special casing, because I've got to do a loop inside here now, layer, and then there's a loop carry dependency in this layer, because this one writes to here, and then this one writes to here, and so on. So this is probably not a naively vectorizable loop, because of that operation, and the thick compilers we have at the moment, at least, probably won't vectorize that for us. And also, the thing that is executing this kernel needs to know about how for an arbitrary size thing, how much overlap there is, because it needs to know, for example, that it can't execute. So if it's cast stuff up this way, it needs to know that it can't also execute something here in parallel here. So it's got to do some sort of colouring arrangement to get that, and that's a more complicated operation now because of that. So both what happens inside here and what happens outside here are a bit more exposed complication because of this. I'm trying to think whether this gets worse if I have more of these things here and I want to enable, yes it does. So if I have more of these things here and I want to enable this thing to extend over more than one column, then I can't just pass high-low in. Like this thing would have to have some conception of where the columns ended in what it had been passed. And so that further adds to the complication of what the user has to do in here. So it becomes more and more exposed to the kernel writer, how they have to take into account what the kernel executor, I guess, might do with
So trying to figure out whether this problem is specific to any finite element people do things where they want to loop over elements.
I think this turns up whenever you have overlapping stencils, and I think you kind of always do.
But I think, well, that's related to the two versions of opera R that Rupert presented previously, where if you loop over the corner points and gather information from around you rather than several elements trying to write to the same corner, then do you avoid all this?
you're the bare minimum imposing on yourself a big recomputation penalty for doing that in at least some cases, right? Because of the fact that there's shared computation here. So if you invert, you're at least you're at least putting in a. So if what you want to say is I disallow from kernels the construction of the normal contribution calculation PDE method, I think that's a pretty big set of handcuffs that you put on the way that you write your model.
You mentioned temperature, but if it's a C grid, that's it. If you're doing something like du guide, you said, okay, I could.
Fine, I'm not claiming. Sorry, where does it say temperature?
T. Oh, sorry. T.
That's just a bit of
It's just a variable.
It's a bit of
Right, okay, but there's certain things you're going to have to be careful with.
It's a variable which has an overlapping stencil, and I think that that's such a pervasive thing that I think you'd be imposing a really strong.
I think you're going to have to. If you're doing a C grid or a complicated grid like that, I'm not saying you will do, you're going to have to do this in different ways anyway.
I don't know about the rest of you, but
You're going to have different variables, different ways.
I can't deal with this abstractly. I need to actually try it out with some real code. And I suspect that other people in the same room aren't as good at abstracting this.
Okay.
I think maybe we need to think about the rules of patterns. So one way around this is to do the colouring. So,
but the colouring is quite so. The one way it's so I agree. No, colouring deals with it. It's just that the colouring rules are more complicated, and the stencil rules are more complicated when you have flexibly sized units that you operate on.
yeah, but if you're colouring in the vertical as well, that's the horizontal, then all that complication is hidden from the science user because it's
I
in the
almost
task
agree.
contract.
If your kernel, so this becomes very simple, but the question is what you might, so the specification becomes simple, but I can see that you may have to do more complicated things to get your performance out, so that's trade-off. And the specification becomes simple if you were to make the expansion, to not have this expansible kernels concept. So if you said that my kernel will either be one of these things, for the dynamics case, and there are some options about what that could be. So it's one unit like that, or maybe one unit like that if I'm doing a difference over this thing over these two, but one fixed thing that moves with a fixed stencil, or alternatively the whole lot for those cases that can't treat things as a fixed stencil. So if you have fixed size, and you say, and those fixed sizes could be of different sizes according to what the operator is, but if you make that size fixed, then everything that happens in here becomes fixed. And so the kernel becomes simpler, and then exactly what you suggested applied. So if I needed to do vectorization on this column, if I wanted to apply small scale, fine scale operations, then what I need to do is color the column, and what would effectively happen is, in this case, I need two colors. Those two would be green, and those two would be yellow, and I'm allowed to execute those two at the same time because their rings don't overlap, and then I can exercise those, do those two at the same time, and you get the striping operation out. But to get a low-level vector unit to do that, you might have to do some surgery, which is going to hurt. So I see this comes back to a problem that I think we acknowledge we haven't fully dealt with, which is what do we do about the really fine scale vectorization stuff that starts to impinge on the kernel? That's
a really good reason for not saying the kernel must either operate on a cell or a set of completely unlinked cells, so you could have a horizontal colouring and then just pass a whole bundle of ones that are independent, or operate on columns.
So the reason why you choose, so the reason why you want a kernel to act on more stuff at once is, broadly speaking, so you can get vectorization to work. Whether you want vectorization, whether you always want vectorization, whether you would achieve vectorization across a whole load of unrelated.
Well, you were talking about kind of repacking them about repacking and rewriting the data into.
So if you're doing it in a
Into
GPU
arrays.
context where you have a really limited amount of local memory, you kind of need the things to
Writing
work
took a
on.
lot together, even though they were independent.
Well, the problem you have is that you're really, really poor on local memory, so you want to reuse a lot of local memory.
Yeah.
So if you were doing, in the GPU vectorization case, and possibly also in the big AVX vectors that you have on an Intel mic, you probably want your vector lanes to do this, and then all the local vectors operate alternately, but on the same data. And that's probably what you want, I think. But I could be wrong here. This is starting to get hard and technical.
So I'm with Stephen. Use case and then explore.
That is the use case, but
Yes.
Well, that
Oh,
is the
Well,
use case.
it's
That'll be a good use case
The,
to have a look at it.
if we could capture that
I
use
think
case.
difference
you're
of-
beyond
well,
most
difference
people
operators.
understanding the
We
issues.
want to do.
One of the reasons why early on I think we were keen for the vertical to appear explicitly is because of the physics problem. Things like a convection scheme that goes up a column, searching, looking for unstable layers, doing stuff.
I'm so I'm a little bit less concerned about that. I can understand why that falls out. I think it's more a question that you total flexibility. So expecting the kernels to operate on unknown amounts of data complicates the kernel.
Yeah. You're happy if you give it a whole column.
The known amount of data in a whole column. I think that there are circumstances in which handing it a whole column would be a performance problem because you'd end up with a very big amount of work.
Yeah.
So my initial claim would be that that should be a permitted option, but an option which is exercised only when there's a kernel reason why it needs to occur,
Yeah, so
rather than a default.
local gradient operating, you do that on an element.
On an or on a. If I was doing finite difference A grid on this, for example,
Yeah.
then my groupings, if I was doing finite difference A grid in the vertical, then my groupings would need to look like this, right? I have an edge here, which needed these two. And then I have an edge here, which needed these two, and so on. And then I'd have a somewhat similar pattern, but I need 3 colours instead of 2 because this one still overlaps with that one.
Within that, you would also be happy if we reach up the whole column, as long as you look at the whole column.
If I knew I had the whole column, although the question mark is then for the fine-grained parallelism about whether that's that's a wonderful idea. And there's a way you can specify. So when we talk about kernel interfaces and specifying things that the outside would need to know in order to do the colouring, you can, in the one-dimensional case, there's a very easy way of specifying the stencil because you can always think of a one-dimensional mesh in terms of offsets. So when I'm executing this element, then its stencil might be -1 + 1. Because, and that describes, and that will give you enough information to work out and in this case its stencil might be 0 - 1. And then you can see actually that because this one has a stencil width of 2, it needs 2 colours, and the other one has a stencil width of 3, it needs 3 colours.
So popping up stacks.
Yes, where were we?
Where were we going?
I was just thinking we need a summary of the impact of that discussion on the
It was
kernel.
the stage we were saying, when do we dereference the data?
Yeah.
When do we turn an object into more arrays with regular process, which then spark, as the suggestion was, we could do it in the comp side layer outside the kernel, as we generally probably would do that. But then we spark this issue, which is if we have a malleable kernel, i.e. you can change the amount of data you put into the kernel, then there is this spark this issue.
I think that issue's there whether you do reference inside or outside the kernel, because you still need to know that.
But if you have fixed sized, so where the reason why this concept is relevant is if you have fixed sized kernels and you do reference outside, then you get this nice situation where that kernel is now written in terms of plain arrays with literal constant bounds on them, which is giving the compiler a running chance of doing the right thing.
So that's the big issue. How do we give as much information as we can to the compiler in the kernel?
And so having complicated data structures in the kernel hide stuff from the compiler. Having simple things in the kernel present stuff to the compiler.
So you're I think, arguing against having the low-high stuff like I presented before and saying that we should actually try and have a fixed bound so the compiler knows.
So there's a flip side. So I'm arguing against that from the perspective of what it does to the complexity of this stuff. I'm still, in both cases, nervous about how the hell we get some of the vectorization to work at low level. I think if these units do enough work, then this does it by itself. And that's more true for higher order schemes. So, you know, go fifth order and third order, and we don't have any problems here at all. But for very low order schemes where there's not a lot of work in the kernel, then it's much more tricky to work out how you do that. But also low-high doesn't help very much because low-high, or in and of itself doesn't help very much because low-high means there are variable bounds here, which means the compiler doesn't know that it can safely vectorize. So neither of those are immediately ideal solutions, unfortunately.
So there's one thing about compilers.
The low-high could help if you said you were going to give it stacks of columns, because then you have an inlet with a column which is fixed, and you have the outer over the number of columns.
Well, but once
which is limiting you, but
once you've done that, I would claim you don't need the low-high anymore because
you've already got a big package.
You've got a big package of stuff to do.
Well, I'm thinking about the Thompson's integrations of no column, where to do on several columns at once is one way to recover vectorization.
Right, but you can doing it on. So this is it depends what you're prepared to do. Kernels, I guess, is the answer.
But I think we need a greater corpus of experience.
Yes.
Mm-hmm.
Right. In terms of compiling efficient code for the particular architecture we're on, and in terms of being able to block for the cache use outside that, I think that's high lows are
that was the point.
Targeted
I
cache
guess
blocking.
the question is how useful that is.
So can you still maintain the cache blocking ability, flexible ability, and have highly optimized compiled code?
So if it's just for cache blocking.
Well, it's not just for cache. Cache blocking is
for the cache blocking issue, you can do it by controlling the order in which you execute kernels compared with data, right? And in fact, that's exactly what OP2 does. So OP2 will block bits of the mesh and hand a thread, in the CPU version, hand a single thread, a chunk of things in related memory, and evoke the kernel for each of them. And that causes you to efficiently use cache.
So the argument.
The other optimization was the data access stuff that you were showing. We need examples we can work on.
I mean, do you think this is a clear solution here?
No, I don't think it's a clear solution. The reason I don't think it's a clear solution is because it's still, and we have a PhD student currently working on how you get vectorization to work with this.
So it's probably a good idea for us to try all these different.
Nothing that I currently see on the table transparently makes the fine scale vectorization easy. I think it's quite hard for all of them, completely unaided by the fact that our experience so far is that the compilers are really obstinate.
So it does sound like we want to have a few different types, don't we, and play about with them.
I agree with Stephen and John. I think this has got to be tried out.
Well, I think if we could avoid having the open-ended low and achieve the same thing some other way, that would be.
There are some intermediate options here, right? So it's possible that there's a loop level at which one or more columns happen, which is different from an arbitrary high-low effect.
Yeah.
It's kind of a, and that might be something that might fix some of this.
To be investigated. So we see what else I can provoke. Base models.
Yeah, who allocates the data and where's it allocated?
Yes, so
does
there
the
is
infrastructure do it, who's using it?
Yeah.
That's the question.
It is.
Sorry.
No, that's the question. Well, at the minute, I don't think we've got a handle on where the best place to do this is. My suggestion was most of the data could be allocated in the init routine of the model, because it's the model that knows about it, and that seems a sensible thing, but we've not really thought through all the implications of that, so I don't know if anybody's got any.
So Warp, one of the things they do is allocate all the data. You specify what you want, and they fill in the gaps where you would have to write it yourself.
Yeah.
Whether that's a good thing or not, I don't know.
The problem with WARF on this, we've got it on the IBMQ, is the way they allocate the data is just not suited for massively parallel type structure.
Right.
And it really is, and this is the problem we're going to have.
So what's wrong with it?
Yeah,
What's wrong with it? I mean, it just doesn't work.
No, that's a symptom.
Yeah. Do you understand
what
what
does
the
it
issue
do that
is?
doesn't work?
Well, I mean, it just takes so long because it's a serial process. So the way they've structured the initialization is a serial process that isn't designed for.
Is that reading in initial data? Is that what you're talking about?
Well, you're initializing the model structure. I mean, you know.
So the model init of WARF, you're saying, takes a long time. And
It's going to make it impossible for us to do the simulations on this, unless we put it on a different type of. The way it's been structured, they're initializing all the fields and setting the whole thing up, is designed on a sort of serial stroke vector type approach, and I would strongly recommend that we don't do that.
So you think that's what we've
But
done on each API thread?
But do you know what the bottleneck is? Presumably it's not actually allocated, it's I/O and working out of tables and things?
I'm assuming it's that, but it's a. I mean, the point is, you're going to massive data sets, which is what the meta is going to do. You're going to have 2 kilometre grids or whatever. And it doesn't matter that we want to load in 1,000 days. It doesn't really matter quite low risk, well, 3,000 by 3,000. It's the fact that there's a lot of information coming in.
So that is one of the. So I think there are.
So when you allocate the model, I'm talking about data in this, which is slightly different, I know, but this is.
So I think there's actually 3 steps in getting a field that you can work with.
That's right.
So the 3 steps are, you have to have the structures there, which are sizes and more than sizes. So sizes, halos, all that sort of infrastructure stuff, the stuff that I would call the function space, the thing that gives the structure to the field. And that has got to be provided by the infrastructure, and there's probably strong reasons for doing it up front and getting it sorted. Then there's the producing the data space for an individual field, allocation of that, which is basically just allocating a degree of a list of DOFs and associating it with its structure. You might even think about just having a field struct which contains a data pointer and a structure pointer that points back to where stuff comes from. You can get more complicated than that, but at the dumbest level, that's what it might look like. And then the 3rd step, which is the one that Alan, I think, is currently concerned with, is populating that with values that might be coming from disk, for example, which I think is not what's directly being addressed here.
I haven't
It's
talked
not.
about.
No, we're talking about who allocates the data.
But sure, yeah, but that 3rd stage does depend on how you structure the first 2 stages, doesn't it? As well. I mean, I agree it's totally different.
So I think that one of the things that came up in earlier discussion is I think that there are a bunch of reasons why you would like to think that the structure all happens in model init.
Yeah.
Lots of things, life gets made an awful lot easier if you can assume that once the structure's there, it's going to stay queried. Something came up this morning that indicated why it makes your user's life a shitload easier, if phase 2 doesn't always have to happen then. So the example that was given is if I'm a random user and I want to hack in a diagnostic so I can find out what the hell is going on, it would be really helpful if in algorithm code here, I could basically say allocate temp field, pass temp field to kernel, put temp field, deallocate temp field. And I think as long as that temp field is being allocated on a structure that already exists, no really hard problems, hopefully, are presented by allowing people to do that on the fly because it doesn't change structure. There's an important difference between structure and content there.
It's a whole field operation, so it's collective, so it's some rules about what you do it.
Absolutely, it's a whole field operation. It occurs, well, I think almost everything that occurs in that top block will have something like collective semantics. I'm sure there are exceptions, but certainly all the obvious things you do in that top block are collective.
From an allocation point of view, I think ESMF gives you both choices, doesn't it?
It does.
You can either specify to it what you want, and it will return a data structure with the allocated data to it, or you can pre-allocate the data and register that with it. So you can do it either way around in ESMF, I believe.
So really we're saying that talking about the step 1 and step 2 part, which is the first one is calculating the data structure with i.e. sizes, how big the halos are.
Probably reading from a file, I suspect.
Yeah, I think and then stage 2 is when
Then you say, okay, now I want one of these things, and I'm going to call it Bob, whatever. And when does that get allocated? And those two things are not the same thing. You say ESMF allows you to do them both at the same time or do them separately.
No, you can use the information you've loaded in order to give you the data. If you give it the sizes and everything, it will then give you the data. So that's the two together in some senses, I suppose. Yeah, but it returns it.
It returns a pointer to the data it's allocated, or you can allocate the data in your space and give it the pointer.
Oh, I see. Okay, right. Sorry.
That's fine. But I think
But
we're only going to have a certain number of types of fields. We want to set those up once and then create lots of instances.
Right.
Of those.
Yeah.
That's different. Actual arrays.
And also bot up here should not see those two, right? So whichever one of those two we're doing, person up here should say call allocate field structure, and malloc should occur somewhere in there, and it's a below the infrastructure hood issue that can be negotiated according to what's convenient as to whether ESMF did that or Unified Model did that. But
So you think so this is saying that the user is responsible for saying exactly all the fields that it wants, and then they get registered and allocated by the infrastructure or something. An object is returned.
So I think that there's probably a spin-up. There's a setup thing where you get. So there's two cases here. Right? One is your persistent fields that record your state, temperature, whatever. We can call them prognostics. Some of them might actually really be diagnostics, but they're persistent. They're things that hang around. Some of them might even be prescribed and forcings sort of look like this as well. And you have a spin-up where they occur and they get allocated, and they probably get shoved into some sort of state object that you get handed. So when you are in the algorithm layer, you get handed a state object, or you get handed an unpacked state object. You can so somewhere around here, state unpacking occurs, and there are legitimate implementation and API choices about whether it happens here or here, but that's about where it happens. And so those things are kind of set up once, but they're set up probably by code that's going to call exactly the same routine, they call allocate field or whatever. So it's also the case that I might want a temporary, and I can do that by calling an allocate on a field in here on an existing structure. And at least the fluidity and icon way of getting that structure would be that the state object which you get doesn't just contain all the fields in operation, it also contains all the available structures. So that's where you get them out of there from. But I mean, you can envisage other ways of doing it, but that's a way that you could communicate that and get a thing at this level that the user could cope with and deal with.
How does this relate to the registry, which is where I think to do a temporary field, you would simply go in and write in Nigel's temp field type, whatever, into the registry, and then that would automatically be available, as I understand it, where you want it.
So I think David's providing a different solution to that by saying that you can register it as a part of that level rather than having to go into a separate registry and populate things.
Yeah.
I think that's what it's
That is what I'm saying.
So I think possibly you were talking about something that would exist for the whole
Yeah, I don't
length of
understand
the
how
programme. You're adding one in temporary in the sense that you're going to remove it when you finish with it.
I can imagine one way
I
of
meant
Whereas-
temporary for the run that I'm doing.
Whereas
That's what
Dave's
I'm
talking about
doing.
temporary just while you use it, and then it'll go back into a pool to be used again
Right.
for something else later on.
Yeah.
So
It's two
are we
different-
talking about data that the user might want to output as a diagnostic?
So yeah, you want to do something, get some diagnostic, spew it out, and you don't need to keep it
So
around.
if you want to output it as a diagnostic, you need to have it registered somewhere so that the diagnostic system...
So
But you could have, but say you were doing something that was competitive down, you might need an array to store that data in when you do the calculation, but you've got the answer out, a single number, you can send that to the diagnostics.
Yeah, but for the meaning of the single number, you need something
Yeah,
outside.
that has to be registered as well, yeah.
There's some structure there.
So are we talking about there's a pool of memory that we construct in a certain size and shape, and then if we're on temporary, that thing persists, and there's more of it than we need at any given point when we're reusing it?
That's an implementation choice, but it's one that as far as the user, as far as the user is concerned, that's kind of indistinguishable from actually calling malloc free.
Right.
But you can, but you can absolutely see reasons why you might do your own management rather than just calling malloc free all over the place. But yes,
So this would mean you could add diagnostics without having to recompile.
no, that's not quite true because you're still adding code lines in.
So if you're going to recompile anyway, why not use something that's static?
So I would claim that they're kind of equally static as each other in the sense that they're both caused directly by the code that's running. And the difference here is that this one requires me to change one file with local semantics, where if I get it wrong, I'll get an immediate compile error. Whereas the other one requires a much more global change to the...
But that's what the point of a registry is, it knows where to put things, so you can...
So, I mean,
I'm not sure that's
is it used,
practical, but that's the idea.
is it use case something on tiles where you may, your model may model different types of vegetation, so the number of vegetation fields depends on whether you've got trees and grass and different types of trees. So you've probably got a loop in your model that says, I want to output all of these diagnostics, and there might be 1, there might be 5, there might be 10. So you do your loop and 1, 2 number of tiles. But each of those fields is has a different meaning to the outside world.
What's the question?
So the question is, that's a number of different fields without recompiling.
Right.
It's certainly not obvious to me that there's a significant performance issue about the number of fields that are in existence that would cause you to need to know that at compile time. And so that certainly is facilitated by having something that the user has access to, which builds things. So it's certainly true that the diagnostic system, when it fires up, would need to know about this. But that's fine, because this is like, I don't think anyone's seriously contemplating an interactive UN. So when you launch, there's a configuration file that says that this diagnostic field exists, and that means that bit that's handling diagnostics knows it exists. Bit that builds it knows it exists.
It's exactly what Wharf did. They have a registry, and again it's an implementation detail, but they had a registry and they specify the type of what you were going to use of each of these things, whether it was a diagnostic or whether it was a state or whether it needed input or whether it was going to be output. And then they created everything. And MPAS got away from that.